Hi guys, so we're going to start off with chords and arcs today. So we're looking at this section, we're going to come back to the standards that prove the properties of angles for a quadrilateral inscribed in a circle and identifies and describes the relationship between central, inscribed, and circumscribed angles. Vocabulary review really fast. Remember, an inscribed angle is an angle whose vertex is on the circle and its sides are chords of the circle. So this angle right here is an inscribed angle. Inscribed angles create intercepted arcs. Intercepted arcs are essentially the arc that you'll find on the circle when you follow those chords to the other side. So the blue arc here is an intercepted arc. So a couple quick theorems today, and then I'll upload a separate video to work out some problems. The first ones are pretty straightforward. I'll go ahead and grab my highlighter here, the nice yellow highlighter today. The first one talks about an inscribed angle, and the measure of this angle here is half, nice typo, the measure of the intercepted arc. So whatever number we have here, it's half this arc that's intercepted. So if this were 60, then this arc would be 120. The next theorem that we have going on today deals with corollaries to the previous theorem. The first one says that if you have inscribed angles that intercept the same arc, they are congruent. So if you notice, I have this arc AC here, and you can see that angle D is inscribed in AC. Angle B is also inscribed to AC, and angle F is also inscribed to AC. That means that all three of those angles, since they inscribe the same arc, are congruent. So all three, angle D, B, and F, will have the same measurements. Then our next corollary to that theorem talks about an angle that's inscribed in a semicircle. So I have a semicircle here. You can see that the diameter goes through the center O and creates the diameter XZ. And then the third point on the line creates point Y, giving us a triangle of XYZ. Since this angle is inscribed in a semicircle, then we know that the measure of that angle is 90 degrees. The last corollary to this theorem deals with quadrilaterals, which are inscribed inside of a circle. And what you'll notice is that the opposite angles of the quadrilateral are supplementary. So A plus C equals 180, and B plus D equals 180. The last theorem that we have today talks about an angle that's formed by a tangent. You'll remember tangents from the last two sections, and a chord. And the nice thing about this one is that this angle, which is formed by that tangent and the chord, is 1/2 the measure of the arc. So if this were, say this angle here were 80, then the arc measure would be 160. If the arc measure from BCA was, say, 220, then my angle 2 would be half of that measure of 220, which is 110. That brings us to our last slide and the separate worked problems. So I have about 4 problems I'll work out on the document camera and upload for you guys.